I'm Li Kai, so thanks for joining me in this virtual conference. I'm from University Technology Sydney, and today I'm going to represent my topic of feature selection approach for optimizing music emotion recognition methods. So music takes an important role in our lives. So whatever you're shopping, you're studying, when you're exercising, even relaxing, you always hear music. And music is in sense of emotions. So it can influence people's mind, and it also can correlate emotion-related informations. Therefore, the study of music emotion recognitions become a focus of research, and it has been taking for effort and expanding during the past decades. So before we dive into the concept, we need to understand how music emotion recognition system works. So firstly, the music emotion recognition system works by detecting music emotion from audio signal. So it actually extract the music features from labeled music and mapping it to a emotional models. So in this case, we need to train a competition model to do the recognition task. So um, after that, we can the computational model works by taking the labeled music with its features and then uh, with its corresponsible emotion labels and yeah, sorry. Um, um, the enable music and taking into the input of the computational models. After that, it will produce the emotion label. So before we dive into the labels, we need to understand how to conceptualization the emotion. So the emotion actually being taken from the music feature actually being taken from the music signal, such as rhythmic features, timbral features, and spiritual features. We need to think about how to map it into a emotion. So how we gonna model it? Currently there's a very popular many two approaches, which is categorical and dimensional. So, the most famous model for the categorical approach is called Haiyan affective rings, and the most popular model for the dimensional approaches is called the Russell circleplex model of affairs. So the categorical model represent the emotion by its discrete classes. So the basic classes such as happy, neutral, anger, and sadness. And the corresponding model can be used for machine learning. For categorical model can be SVM or decision tree or k-nearest neighbors. For a dimensional model represent emotion by continuous values. So basically, the emotion is being represented as a point in a unit circle and it has two axes, which is violence and arousal. So these two axes means how emotion from positive goes negative goes to positive, and arousal means how emotion from weak to strong. So that means the higher violence means happier, the lower violence means more upset, and for the arousal is the higher arousal means more excited or energetic, and lower arousal means more calm and relaxed emotions. So the corresponding machine learning models can be used for dimensional approach, such as SVR and random forest regressions. So, before we model the emotion, we need to think about its music features. Because currently we don't know which features are useful for the music emotion recognitions. So we can get a clue from the standard audio features, such as rhythm rate features. We have tempo, beats, spectrum, loudness, onset, or densities. And we have dynamic features such as IMS energy and levels, loudness, temporal weights. And we have mute melody features such as pitch, prudence, and pitch strength. And we also have harmonic features such as chromogram, key, tonal central, and sharpness. Lastly, we have tonal colors such as MFCC, attack times, HFCC, HPCC, etc. But standard audio features are so many. We don't know which one would be useful for the emotion, particular for the emotion recognition. So in this case, if we have a high feature dimensionality issues. Also, if we use all of the standard audio features, it requires very high computational cost. Also, the features doesn't really relate to the emotion can also cause noise and has the bad effect on the model stability. So, our challenge for the MER can be summarized as in follow. We found currently the music concept is lacking computational extractor because we don't know which features are formative to the emotion, particularly. And second, the MER task generally requires large computational models because generally the MER use the most of the audio features and fit all of them in a bunch of algorithms. Then it has the high demand of computational powers and also the unrelated or irrelevant features can cause noise and has bad effect on models' stability. So for our objective of this research is to trying to develop a feature selection approach that can improve MER performance without knowing in advance on which features are useful, particularly to the emotion. So for our experiment, we can be categorized basically in 4 stages. So pre-processing, feature selection, and model training, and evaluation and benchmarks. So for pre-processing, we're using the Open Spiralboard toolbox to extract basically all standard audio features, and then we normalize it in and filled into a feature selection algorithm to generate a subset that has the most relevant features towards two emotions. After that, we training our models using two subset. One set is the data set with all features, all standard audio features, and then one set with our selected features. Then we finally do the evaluations and benchmark of two of them to see if our hypothesis has made sense. So feature selection stage basically contains of these 3 steps. So firstly, the feature extraction. Like the actually creates a feature vector using OpenSpire toolbox and just normalizing them into a vector. After that, we do the feature selection steps. It recursively selects the features and placing them into a subset. And then after that, we have feature ranking. So we will score each features based on its accuracy and inference towards models, and then we generate the final feature subset based on its ranking. So the feature elimination stage actually takes all the features into a subset buffer, and then we do a 10 cross validations for every subset, and we trying to track the each feature's performance, and then we select the final best features in a subset. So the last stage, we do the validation and the benchmark stage. So firstly, we need some data. So we have 2 subsets generate. One is called a completely feature set. That's the feature set with all the standard audio data remain untouched. And we have the selected feature set generated by our proposed our feature selection algorithm. We split the data into 2 sets, one for training and one for validation. After that, we built and trained the models using these 2 sets. So we actually select the 2 most popular machine learning model for the MER task. So one is the Support Vector Regression, and one is for the random forest. And in the last, we benchmark the result based on individually of these 2 models. We evaluate both model performance on completely feature set and the selected feature set. So the result we found, we actually has reduced the feature dimension, and we found the optimal result is by using the features in combinations, and also found SVR model has the best performance in overall MER task. So actually, we found also the arousal has the most efficiency on the dimensional reduce rate. So for the model performance benchmarks, we benchmarks these 2 models together. We found actually our SVR model has improved 12% on arousal, and 70.5% in violence. And the random forest model also has been improved by 74% on arousal and 4.1% in violence. So we also do the model statistics benchmarks. We applied the 10-fold cross-validation for these 2 models, and we also found the statistics reducing feature dimensionality improves the statistics of the model. So the SVR model has actually improved about 4.2 and reduce of 0.51 in standard in arousal, and For the awareness, it has also improved about 4.6 and reduced about 0.11 in standard deviations. So the same story applies to the random forest models. So it actually has improved about 2.9 for arousal and 1.3 for violence. So in conclusion, we found there's no dominant features for the emotion recognition task. The best results is achieved by using the feature by combinations, such as using MFCC, spectral and chroma features are most relevant to the emotions. And also we found the SVR models has the best performance on the immersion recognition task. And also the arousal recognitions has the higher performance was to the violence. And also we to summary, we found reducing feature dimension thus has the potential to improve the MER performance. Since we from the result, we found the SVR and random forest, the performance has actually been increased, and their variation statistics has been increased as well, using comparing them with the our selected feature set was to the complete set. But so for the future work, we also aware there are some limitations of our approach. So firstly, since our selected feature set is derived from the Mediaeval set, so it's not genetically involved. The same performance might now apply to other data set. Secondly, we found the feature selection algorithm is relying on the learning model, so it may has bias on different machine learning models. Also, we didn't really consider about the time varying factors, because in nature, the music is like a signal. It has the emotion will varying based on time. So in the future, we can consider about more advanced models such as seasonal support vector machine, which is can be handling time varying factors. Also, lastly, we found splitting the violence and arousal may now will cover the combined relationship of an emotion. So the possible solution can be develop a more hybrid feature selection algorithm approach based on takes the violence and arousal into consideration at the same time for the further research. So let's probably consider about my presentation. So thank you everyone for your time.